What is the basic difference in permutations and combinations? By definition, in permutation, an arrangement or order matters. So, for example, let's say you have 50 students in a class, right? And let's say they are competing for gold, silver, and bronze. Okay, the order would matter. So basically, in the case of permutations, what we're doing is um, we're, we're basically arranging 3 students out of 50 students, right, in these 3 places, so gold, silver, or bronze, right? And the order definitely matters because it's either first place or second place or third place, right? And that is denoted by 50p3. So we are permuting 3 students out of 50 in this. Now it could be any 3 students, right? So basically choose any 3 out of those 50 and then decide which one gets gold, silver, and bronze. So there are so many possibilities. In combination, the arrangement does not matter. So let's say you have a squad of maybe 20 soccer players, right? And you have to choose 11 to play on the field, right? So forgetting substitutions and everything, let's say we need to choose 11 to play on the field. The order will not matter because it will still be the same team, right? No matter which 11 players you choose. So that's an example of combination, right? So we are just making a choice of 11 players. We are not arranging them. Yeah, another example of a permutation could be, let's say you have a lottery and you have first, second, third, fourth, 5 prizes, right? And let's say maybe 10,000 people play the lottery, right? Any five could win. Any five could win, and in these five, they could be winning any prize, first, second, or third, fourth, fifth. So that is basically what a permutation is. The order of selection or the arrangement of the choices that you made will matter. In combination, the arrangement will not matter. Another example of a combination is basically, let's say you have 10 choices for 10 dishes for dinner, right? And you order any 3. I mean, you could order them in any sequence and it's still the same 3 dishes that you get for dinner, right? So those are examples of permutations and combinations. So permutations is the process of arranging k objects from a total of n objects. And what is important in permutations is that the order of choosing those objects or arranging them matters. So permutations, it is written as npk, and that is basically means that we are choosing k objects from a total of n objects. It is also important to introduce the concept of a factorial. Factorial is basically an integer multiplied by all of the integers below it up to 1. So if you have, let's say, 7 factorial, it would be 7 into 6 into 5 into 4 and all the way up to 1, and then that is basically equal to this. So mathematically, let's say you have n objects and you want to basically arrange or make an arrangement of k objects out of them. This would be equal to n factorial divided by n minus k factorial, and that doesn't make sense if you look at it that way, but how to understand this? So it's very easy to start with, let's say, two objects. For the object, let's choose numbers for now because it's very easy to play around with those. So let's say you have 1, 2, 3, 4, 5, and up to n numbers, right? And for now, we only choose or arrange, we arrange two of them. So we have basically two choices. I can basically put one here and maybe three here, or I could put um, two here and maybe seven here, right? And these are different arrangements, as well as if I put 7 and 2, these are considered different arrangements as well. So how do we do this? So let's say I have n numbers, and maybe I have just two spaces to arrange them. I can put any of those n numbers here, right? But let's say if I choose one number at first, it could be any number. Let's say I choose 1, right? How many choices are left for this one? So I already chose 1. I had a total of n numbers, which means I have n minus 1 choices left here, right? And for the first one, let's say instead of 1, I chose maybe 2. How many choices would I have left for the second one? It is still n minus 1, right? I mean, I could choose any number for the first box, and I could choose maybe 12, and I would still have n minus 1 choices left for the second one. So no matter which number I choose for the first box, right? I have 1, 2, 3, and up to n. I always have n minus 1 choices for the second box, because that one number gets blocked with this box and I can't choose the same number again. So I could choose 1, 2, 3. I could basically choose even n, and I have n different choices for the first one, right? And each one of those choices is going to give me n minus 1 choices for the second box, right? So how many of these are there? So n minus 1 choices here, n minus 1 choices here, and then n minus 1 choices right up to n. So there are n of these, right? So in total, I have n into n minus 1 choices. And let's say instead of picking 2, I am now picking 3. So let's say I have space for 3, and again 1, 2, 3, 4, n, and basically I'm arranging them. So if I say 1, 2, 3 and 2, 3, 1, these are two different arrangements, right? So let us focus on just the last box. How many choices would I have for the last one? So let's say I picked something here, right? So I filled this one, I filled this one. So basically I used up 2 of the numbers, right? So for this one, I would have n minus 2 choices, right? And I could pick any of those first 2 numbers, right? They would still give me n minus 2 choices. So basically I could have 1 and 4, or I could arrange 4 and 1, or I could arrange maybe 5 and 11. Each of these would give me n minus 2 choices, right? And that means for every combi or every arrangement of the first 2 boxes, I get n minus 2 choices. But in total, how many possibilities are there, or how many cases are there for the first 2 boxes, right? It is not obvious here, but we actually calculated that here. So if we had 2 boxes, we had a total of n times n minus 1 possibilities. So we have n minus 2, and this is for n times n minus 1 possibilities for the first two boxes, right? So in total, how many ways to arrange three numbers are there? It is going to be n minus 1 into n times n minus 2. So this is basically the third box, and then for the first two boxes we have these many different ways to arrange two numbers in the first two boxes, right? So this is basically n into n minus 1 and n minus 2, and there is a pattern here. So let's say I had four boxes, right? I basically have to put three numbers here, and that leaves me with n minus 4 choices for the last box. And from this you can see that for three numbers I have these many total possible arrangements out of n. So it is going to be, for four numbers it is going to be, let's actually make a list of that. So for four numbers is going to be n into n minus 1 into n minus 2. I actually made a mistake here. This is going to be n minus 3 because I chose three numbers in the first one, and then that leaves me with n minus 3. So this is going to be n minus 3 here. And what did we have for three numbers? It was n into n minus 1 into n minus 2. For two numbers we had n into n minus 1, right? So there is a pattern here. In general, if I choose k numbers, right, you can see for 2 this ends in 1, for 3 we have 2 here, for 4 we have 3, so 1 less, right? So it's going to be n minus 1 times n minus 2 right up to n minus k minus 1, right? So it is always 1 less than the amount of numbers we are choosing. And this basically is, let's say you had n factorial, right? N factorial would be n into n minus 1 into n minus 2 all the way up till 1, or maybe you could start up to, let's say I'm going to write this up to this number. So n minus k minus 1, and what's the next number? N minus k into n minus k plus 1, and it goes all the way up to 1, right? That is n factorial. So basically, if I combine this one over here, these terms over here are basically n minus k factorial. So to choose two numbers, to choose k numbers, right, it's going to be just the first part, which is n factorial divided by n minus k factorial. So if we have n minus k factorial in the bottom, all the terms which we don't need are going to cancel out, right? And it leaves us with the part that we need. So that is why we have, for permutations, if we want to pick and arrange k numbers out of a total of n numbers, and this obviously assumes that n is more than k, we have a total of n factorial upon n minus k factorial ways to do it. So what is the difference between combinations and permutations? What we did before was permutations. So basically, when you are picking k numbers and the order of choosing matters, or you are arranging them, it is called permutations. And in combinations you just pick k numbers, but the order of choosing does not matter. So what would be an example of each of them? Permutations, let's say you have an F1 race and there are maybe 20 cars racing, right? What are the different possibilities for the podium? So you have three 3 places, right? First, second, and third, and any of those 20 cars, 20 drivers could take the podium. So here the order matters because you either are the winner or the runner up or the third place. So the order matters here. But for combinations, an example would be, let's say you have a total of 50 football players and you are trying to pick a team, right? So let's say you have to pick a team, and let's say you have maybe some players who are on the bench as backup, someone falls ill, so in total you have a squad of 20, right? So let's say you're picking 20 players out of 50. It does not matter in which order you pick them, it's still the same team or the same squad. So that would be an example of a combination. So these are represented by NPK and NCK. So basically P stands for permutation and N stands for a combination. And what is the difference between those two? So the way we did permutations, right? You had a total of n numbers here, and then you could pick and arrange them, let's say 1 2 3, or maybe 3 1 2, or 2 3 1, and these were different valid cases in case of permutations. But for combination, they are all the same. So basically if you're picking 1 2 3, you have just picked or chosen these 3 numbers. It does not matter if you picked 3 first and then 1 and 2, or 2 3 1. These are all the same in combinations. So obviously in permutations you have a lot of repeated cases if these are combinations. So let's say if you have let's say x number of total possibilities in permutations, right? For combinations you will have much less than x, because a lot of the permutations count as repeated cases or the same case as far as combinations are concerned. So how many cases are actually repeating? Let's say you are choosing k items out of a total of n items, right? In permutations you had, if it was npk, it would have been n factorial upon n minus k factorial, right? And out of these, how many cases are repeating? So if you remove the repeating cases or count them only once, you should get combination, right? So from here, if you do this, you should get to this. And how do you do that? So how many times would one case repeat in permutations? Let's say it was the same example as before, maybe 3 2 1, right? Let's say this number 1, it could have been here instead of there. So basically you could have 3 1 2, right? So whenever 3 is at the first place, if you look at the last 2 places, they can be interchanged. So you have, for the last 2 boxes, you have 2 possibilities always, right? 2 possibilities. And then again, if I had, instead of 3, if I had 1 in the first place, then you could have 1 2 3, or maybe 1 3 2. So again 2 possibilities. And even if you have 2 in the first place, it's 2 1 3, or you have 2 3 1. So again, so 2 possibilities for every letter that is here, right? So So let's say so 2 here, 2 here, and then 2 here. So total of you can have 3 letters here, right? Because we are only arranging 3 letters. So 3 letters in the first place and 2 possibilities for the last 2. So 3 times 2. And this is 6, but I'm going to leave it as 3 times 2 for now. So let's say you had 4, right? And remember, this is just for the case where the numbers 3, 1 and 2 appear, right? So I mean, so this calculation here, it was only for the combination of 3, 1 and 2. You could do a similar exercise, let's say for 2, 5 and 7, and then again there would be a total of 6 possibilities if it was 2, 5 and 7. So in the case of 4, for any given 4 letters, right? So let's say I'm going to choose random letters for the sake of let's say I could have 5, 1, 4, 6, right? So there are 4 letters. So from the first exercise, if the ways of arranging these 3 letters are basically 3 times 2, right? And the first one, any of these 4 numbers can take its place. So 5, 1 or 4 or 6, right? And for any number, there's going to be 3 times 2 cases of arranging those in the other 3 boxes, right? So 3 times 2 for everyone. So in total, between all those 4 numbers, right, 4 numbers, they can be arranged in 4 times 3 times 2, right? And again, so 4 choices for the first box, and then for every choice on the first box there is 3 times 2 ways of arranging the other 3 boxes, right? And this is basically for 4 numbers. This is 4 times 3 times 2, and then I can just add 1 here. So this is basically 4 factorial, right? So for k numbers, it's going to be k factorial ways of arranging the same k numbers. So let me write that down. So I'm going to say the same k numbers can be arranged in k factorial ways. So that means that every unique choice of numbers in our permutations, so npk, right, which was n factorial upon n minus k factorial, right? So we are choosing k numbers here, right? So every unique choice is being arranged in k factorial ways, and if we count those k factorial ways only once, we get the number of unique choices, which is combinations. So nck, right, it's basically eliminating all the arrangements for the same k numbers. So it's going to be npk divided by k factorial ways, right? So this is equal to n factorial upon n minus k factorial and k factorial. So basically it is the number of permutations divided by k factorial, which gives us number of unique combinations.